Hello, I am 2. Today we are going to talk about the properties of exponents. I'm pretty sure that a lot of this will be review, but we're going to practice putting it into more complicated problems. So here are the first rules of simplifying an exponential expression. So an exponential expression is completely simplified if there are no negative exponents. So I'm going to put examples of not simplified over here. So if I had x to the negative 2, that is not simplified. The same base does not appear more than once, so that would be like x squared y x, same base appears more than once. No powers are raised to powers, so x squared squared. No products are raised to powers, ab squared. No quotients are raised to power, x over y squared. And numerical coefficients in the quotient do not have any common factor other than 1. So if I had 10x over 5, I would need to simplify that. So here are some examples of all of those, and we're going to see which one of these rules they are breaking. Some of them, each one has its answer in the group. So if I look at this one, I can see right away that it doesn't obey the first one because there are negative exponents. So first thing I'm going to do is I have to flip that. So I'm going to get BA over A squared. Remember, this is the only part that flips because the exponent only goes to the letter it's connected to. Well, once I do that, then I got to cross cancel that A with one of those, and there is my answer. Okay? All right, here's one that is a product raised to a power. So you have to distribute that, and that becomes a to the 4, b to the 4. Okay, this one down here, the same base is in 2 places. Remember that there's a 1 here. So that's x to the 1 plus 2 is x cubed. Okay, this one here is a quotient raised to a power, so you have to distribute the exponent to both parts, and that goes to this one. Okay, this one is a power raised to a power, and so you go z to the 3 times 4, and that gives you z to the 12th. Okay, this one here is the simplification of that one there, where we had 10 over 4, 10a squared, so the 2 goes into that 2 times and goes into there 5 times. So that is the one for that one. So those are all the different examples that I gave you above. Okay, so if you were going to simplify this, remember the rule. When you're multiplying 2 squared times 2 cubed, then you add the exponents. 2 plus 3 equals 2 to the 5th. Okay, so this would be 5 to the 3 plus 5 is 5 to the 15th. Okay, a number or variable written without an exponent actually has an exponent of 1. So that way when you're doing this, you know that you're going y to the 1 plus 2 plus 3. Okay, you do not have to show this kind of work on your homework. I'm just showing you so I can teach you. Okay, and this is an example of a power of a product. So when you have a power in here, you're going to distribute the 3 to the b, and you're going to distribute the 3 to the a. So this becomes a cubed, b cubed, and now it's simplified. When you have an equation, a term inside and a term outside, then you multiply those terms. So this would be b to the 3 times 2, which is b to the 6th. So here's an example of putting things together. So I'm going to distribute the 3 to the 4. And remember, this is one term. You don't distribute it to the 4 and the 2. It just gets distributed to this. So we get 4 cubed times x to the 2 times 3 is 6 times x to the 5th. Now we're multiplying 2 at the same bases. So this is 64 times x to the 6th plus 5. So up here, when they're outside of parentheses, you multiply. when they're next to each other, you add. So 64x to the 11th. Okay, remember this rule. Okay, this is not the same as this. This one is simplified. This one, I have to do this, so that'd be 4 squared x squared, or 16x squared. Remember, your exponent only goes to the ones it's attached to, but when it's outside, when it's the power of a product, then it has to be distributed to both parts. Same thing here. This is 4x to the 6th. This is simplified. However, this needs to be distributed, so it's 64, 4 cubed is 64, x to the 6th, and that does not equal 4x to the 6th. Okay, so we know that anything to the 0 power is 1, and 1 cubed is 1. In fact, we could have 1 to the 10,000, and that's still 1. So just remember that rule. Okay, down here, do each of these by themselves first. So I'm going to get a to the 3 times 4 times a to the negative 2 times negative 3. That gives me a to the 12th times a to the 6th equals a to the 12th plus 6 equals a to the 18th. Okay? So remember, in your homework you don't need to do this step if you don't need to, but you do need to show some work in order to show me that you're doing it. Okay, here are some examples from your journal. Push pause if you want to. I'm going to work these out, but you should try to do them on your own first. Okay, for this one, you have choices. You could distribute like that, or just like we say in PEMDAS, multiply what's inside first. Either way, you're going to get 100. Okay? For this one, I'm going to distribute to both. So I get 6 squared a squared, which is 36 a squared. On your homework, when it's a square or a cube or something simple, you can go ahead and square it. But if it was like 6 to the 12th a squared, you can just leave it like that. You don't need to do this. Okay? Most of you have a calculator, and the button that looks like that is the exponent button. So if I wanted to do 6 to the 12th, I would type 6, hit the button, then write 12, and then equals, and that would give you the answer. This one would be 3 like this, 3 squared x squared equals 9x squared. Okay, here's another one. Now this one is mainly put here to make you stop and think. So I want everybody to try it. So push pause, and then we'll go over it. Okay, so what this is you have to distribute the 2 to these inside, and you get 2 squared y squared, and so the answer to this one is negative 4y squared. Okay, remember the negative sign is not part of the base. The exponent only goes to this. Okay, so if I have this one, that's different. So this one goes to the negative. I like to do it like this, and it goes to all 3 parts. So a negative cubed, negative 1 cubed is still negative. 2 cubed, y cubed. So that one is negative 8y cubed. Okay, so let's do these. So this becomes, I'm going to go up here. So we get x, so we're going to distribute it to both. We get x to the 6 times 2 is 12, times y to the negative 3 times 2, which is negative 6. But remember, this is a flip it sign, and that's what I call it because it reminds me to flip it. Either if it's on the top, it goes to the bottom, to the denominator. If it's in the denominator, it flips up to the top. Once it's done its job, the flip it sign disappears, That is the answer. Remember, it flips. It does not make anything negative. It has nothing to do with being positive or negative. It is a flip it sign. That's why I don't call it a negative exponent. Okay, so this one here is going to get distributed. So I'm going to get x to the 8th, y to the 12th. Then I'm going to distribute this. And I get x to the negative 8, y to the negative 16th. So now I'm going to flip both of these because they both have a negative exponent. I get x to the 8th, y to the 12th, over x to the 8th. I flipped it, and now the negative is gone, y to the 16th. So we can see that this equals 1 because they cancel each other out. And then 12 of these takes away 12 of those and leaves 4. So my final answer is 1 over y to the 4th. Oops, there's your answers. Okay, the quotient of powers property is telling you that when you have two exponents with the same base, so notice that they have the same base here, then you subtract the numerator minus the denominator. Okay, so this is practice. You can push pause on the recording and do these problems and see how you do, and I will go over them in a minute. Okay, this top one is 4 to the 3 minus 2 equals 4. Now what I do with these kind of problems is I say 2 of these takes away 2 of these, and I'm left with 4 to the 1, which is 4. Down here this is x to the 6 minus 3, which is x cubed. And you could do it this way as well. The problem with doing it like this is that you want to rewrite it so you're not messing up the original equation, because sometimes if you make a mistake you'll erase and it'll erase a number on your worksheet or your test or whatever. So you want to rewrite it if you're going to do it that way. And that way you have the original equation is nice and neat and ready for you. Okay, now I've got a question for you. How does number 4, 3 to the 4th over 3 to the 4th, prove that x to the 0 equals 1? Well, if you look at this problem, that would be 3 to the 4 minus 4 equals 3 to the 0. Well, what does this equal? When we have one term over another term that is exactly the same, that is 1. So that proves that anything to the 0 power equals 1. Okay, this is just to teach you that if you have two things multiplied on top, a product on top and a product on the bottom, you can divide them and then split them. I should say split them and then divide each section before you go on. Now what is the good of this? I mean, I could have just as easily said 12 over 35. However, when you get to scientific notation, it works out really cool. So I'll give you a couple of examples. Okay, so here is a scientific notation problem being divided. So the first thing I want to do is set it up as a division problem. And then I'm going to take each part of it and solve it separately. So I'm going to split it like this, solve this part, and solve this part. So 3 divided by 6 is 0.5, and 10 to the 10th divided by 10 to the 6th is 10 to the 4th. Now the problem with this is if your answer is supposed to be in scientific notation, we know that scientific notation should have one number in front of the decimal, not behind it. So we have to convert it to get the final answer. Okay, so here is an applied example. So the Colorado Department of Education back in 2004 and 2005 spent about this much money, on public schools. This is how many students there were, and they want to know what is the average spending per student. And they want it in standard form. In other words, they don't want it in scientific notation. So the first thing you're going to do is you're going to figure out, well, they want dollars per student. Okay? So to find, whoops, that wasn't supposed to disappear. to find the dollars per student, you divide dollars by students, okay? And so you do this. Now we can split it like we did the last problem. And when we divide that, we're going to get 0.58 times 10 to the 4th. Now that's not in scientific notation, but we don't really care because they wanted the answer in standard form. So I'm just going to take my decimal and I'm going to move it 4 places. 1, 2, 3, 4. Put 2 zeros, and that is the average spending per student. Okay? All right. This is the positive power of a quotient property, and this is telling you that when you have an exponent outside parentheses where there's a quotient inside, you distribute it to both pieces. Okay, so b of course can't equal 0, and if the denominator is negative, that's fine, but remember if you have a negative inside, the exponent goes to the negative as well. What does it mean to write the power with no negative exponents? We've already gone over that. We can't have something like this. So that would equal 1 over x squared. Okay, so pause if you want to and solve these. I will go over them in a minute. These are in your journal. Okay, so this one we just distribute the 2 and we get 2 squared over 3 squared. So we get 4 over 9. This one we distribute the 3. We get 4 cubed over 3 cubed. 4 cubed is 64 over 27. This one we distribute it to both terms. We get x cubed over 2 cubed, cubed. So we get x cubed over 8. Or you could say 1/8 x cubed, but I don't bother going any further than this. Okay, so now I'm going to put a lot of things together just to see how you do. So remember, PEMDAS tells you to do what's inside first. So my first step is to go 2x cubed, nothing on top, and I'm going to distribute that cube. And I'm really glad that I did that first because I can see that those cancel each other. Okay, 3 minus 3 is 0, so that's 1. So now I've got 2 over y cubed squared, which equals 2 squared is 4, over y to the 3 times 2 is y to the 6th. Okay, the next one, I'm going to simplify before I get started. There's 2 a's there, that takes away 2 of those. 1b takes away 1 of those. So now I've got a over b cubed. So that is a cubed over b cubed. And I'm done. Oh, and there's the answers for you. Okay. These properties are written out and explained on page 19 of your journal. So if you still don't understand zero exponents, then you need to go back and read that, and negative exponents. So notice here they give you an example. It is a flip it sign, so it flips it to the bottom. If I had 1 over 2 to the negative 2, that would be 2 squared, which equals 4, because I would flip it up. So just think of it as a flip it sign. Okay, so again, we're trying to mix it up a little bit and get you a lot of different skills here. So check out your term that's inside and make sure that it's simplified. And I see that it is. So now you have a negative on the outside. So what are you going to do? Do not distribute it, okay, unless there's some negative exponents inside. This is a flip it sign. It's telling you to flip everything that is inside. So just flip it. And then you've got a square. Now that you've got that done, now distribute. It's much easier to do it at the beginning. So I get y to the 3 times 2 is y sixth. 2 squared is 4. X to the 2 times 2 is x to the 4th. And I'm done. Okay, the next one, I'm flipping both parts. So I get 3 over 2 squared. The flip it sign has done its job, so it's gone. Again, 2n over 6m cubed, because I had a flip it sign. So I flipped everything inside. Do not move between these until you have done the exponents. Exponents first. So this becomes 3 squared is 9 over 2 squared is 4 times, don't forget to distribute it to every single piece. 2 cubed is 8, n cubed, and then 6 cubed is 200, and I'm trying to remember, 200 and, I wrote it down, 16 over m cubed. Okay, so now I can simplify. So I know that 9 goes into here once, and it goes into here 24 times. 4 goes into itself once, and it goes into 8 2 times. You cannot cancel anything here because they have different bases. So the final answer is 2n cubed over, oh, I forgot to simplify some more. So we'll just do this, 24m cubed, and that simplifies to 1n, the 2 goes into there, and it's n cubed over 12m cubed. Okay, be careful. In this example, the base is negative because the negative sign is inside the parentheses. So this would be negative 3 to the negative 4 would be 1 over negative 3 to the 4th. If your exponent is even, the negative is going to be gone because even number of negatives cancels each other out. Negative 1 times negative 1 is 1. So any even number will always cancel out. So this becomes 1 over 3 to the 4th, which is 1 over 81. I don't know why that does that. Okay, and then in this one, the exponent only applies to this. So you're going to just flip it, 1 over 3 to the 4th. So it's negative 1 over 81. Okay, the base is positive. The negative is not attached. Okay, so simplify. First step is flip it. 1 over negative 5, and now it's just to the 4th. Because it's 4, I know the negatives are going to cancel out. So this becomes 1 over 5 to the 4th. Okay, and you can leave it like that, or you can write the answer figured out. Okay, this one is negative 5. Well, we're going to flip it. So I'm going to go 1 over 5 to the 4th. So that answer is going to be negative 1 over 625 because the exponent only goes to the number that it's connected to. Okay, when all of the factors in the numerator or denominator divide out, replace them with a 1. So, for example, for this one, 3 over s squared times t over 9s squared. So everything gets flipped. So now it's 9 over s times t over 9s squared. Hold on, yes. And so the 9's cancel, and my final answer is t over, I forgot to do s squared. Okay, over s to the 4th, because it's 2 plus 2. And that is the end of this slide. So go and do your homework. It shouldn't be too hard, but you can go back and look at the rules anytime.